This multiplication is the core idea from which all of those other things you just described come from. And this one has the answer, any possible thing. So we call that indeterminate form. Its form cannot be determined. Who's got a graphing calculator handy? Okay, pull that out. And then I got to get on to some other stuff pretty quickly, actually. Graph this. And when you graph it, put this, both top and bottom, in parentheses. Okay, graph it and put, pardon? X squared minus 25 in parentheses, slash, parentheses, x plus 5, close parentheses. Pardon? What won't work? That's window range. Okay, you got the line, right? Okay. Wow. Go to Zoom, and number 6 is Zoom standard. Okay? All right, those of you with a calculator. All right, those of you without, start bringing them. We're going to need them for this. All right, trace, hit trace, hit -5, hit enter. What does your calculator say? Put in zero, no, don't put, hit trace, hit negative, put in -5 for the x. Yeah. What do you know? Okay, those people with a calculator are going to trace, hitting x equals -5, and the calculator is literally saying y equals, and then there's nothing there. Doesn't have a number there at all. Okay? Does not exist. If this shows up in a, I'm going to graph this really quickly. If this shows up in a polynomial, if you get 0 over 0, at that point, you graph what's called a buttonhole. So very quickly, I'm going to graph this line. I'm going to graph this polynomial as if, this rational expression, as if it were x minus 5. I'm going to go down here to -5 for my y-intercept. I'm going to go up with a slope of 1. I'm going to go this way. And at the point 1, 2, 3, 4, 5, -5, I'm going to put in that buttonhole. So if you get 0 over 0, you have to graph an empty hole there. At any point where you get 0 over 0 in a rational expression. You guys can remember that? It's your way of saying this number cannot exist. There can't be a number there. So you have to make it big enough that I can see it. That's one possibility. The other two possibilities with 0 and rational expressions are you get 0 on the top and 0 on the bottom. What do you, now? Okay, so once again, we're looking at f of x equals one function over another function. All right? The x-intercepts. How do you find an x-intercept normally?
You solve for, or no, you just set x equal to 0.
And that's how you find the y-intercept.
Set y equal to?
Yeah, set y equal, that's what we've been doing. We've been setting y equal to 0 and solving the equation, right? Okay, x-intercepts are solutions to the polynomial on top, solutions to g of x. Your x-intercepts are going to be your solutions to this thing on the top. That'll tell you where it hits the x-axis. Solutions to the one on the bottom, h of x, will be vertical asymptotes. We did some asymptotes last year. Anybody remember for what and where what they were?
They were annoying and they were for like exponential growth.
They were for exponential growth. Excellent memory for that. And they were annoying.
Okay.
And they were and decay. And they were always horizontal.
And I did really bad.
Okay, and Dean did really bad on him. We needed that as vital information.
Yeah, so
somebody
that-
again?
Pardon?
Are you going to poison somebody again?
Yes, we will poison someone again, unit after this. Okay? We did horizontal asymptotes last year, and a horizontal asymptote was a line that the function snuggled up to but never, ever reached. Okay, now we're going to talk about vertical asymptotes. That's what happens when you have, well, let me go back about 2 steps. Solutions to h of x. A solution to the polynomial here is what makes it equal to 0. Okay? Then you get 0 on the bottom of a fraction. Are you allowed to have 0 on the bottom of a fraction? So that's another place where this rational expression can't exist, is when you have 0 on the bottom. For some things, okay, let's do an example. F of x equals, I think I know what this one will look like, x plus 5 over x squared minus 4. Keep it simple for now. An x-intercept is where the top is a solution to the polynomial on the top. What makes the top equal to 0? -5. So the x-intercept is going to be at -5, 0. You guys agree with that? You get that makes the top of this 0?
Yeah.
Okay. Where are my asymptotes?
That's where it barely touches the line.
Well, that's, yes, where the function snuggles up to the line and never touches it. And these are vertical asymptotes, and I'll draw that in a minute. But I just said vertical asymptotes occur where there are solutions to the bottom polynomial. So what will give me a 0 on the bottom here?
2.
Not just that.
Either or negative 2.
X equals 2 and x equals -2. So you see how all the solving polynomials we did are going to come into handy here? Come into handy? I don't even know what that means. Where's the y-intercept of this thing? Well, y-intercept is always where x is equal to 0, right?
It's just 5.
Nope. F of 0
-5?
is going to be 0 plus 5 over 0 squared minus 4. So what's that going to be?
5 over 0.
Not 5 over 0.
5 over -4.
5 over -4. I put 0 in for the
Oh.
x's. So that's -5/4. Okay? I'm going to start to fiddle with this graph a bit, and if you've got a calculator, start putting this in, being very careful on your calculator to put top and bottom in parentheses. Okay? I'm going to start graphing some points I know, though. And we'll go into more detail on graphing these without calculators later. Sometimes I've given a test where just half the test is graphing one of these. I won't do that on this test.
But you'll do it on future tests.
It definitely happens in calculus. There's a test that's like just graphing one of these.
Oh, goody.
Okay, now, here's how you draw a vertical asymptote. So I know that's a new idea for a lot of you.